In the last section, we saw how to graph transformations of sine and cosine functions, including vertical stretches, vertical shifts, and horizontal stretches. Now we're going to take a look at how to graph horizontal shifts. For a sine or cosine function, these are not called horizontal shifts, they are called phase shifts. We have the sine and cosine functions set up. The a, b, and d are the same as we saw in the last lesson, and now we're adding in that horizontal shift, that plus c, to determine where our graph will start and stop for one period of the function. We set what's in the parentheses equal to 0 because that's where the function starts for both sine and cosine, the parent functions, and they end both parent functions at 2 pi. So solving these two equations will give us the beginning and end point for one period of our transformation. Same essential question as for 5 day 1. How do we graph transformations for the sine and cosine functions? First off, we're just going to focus on the phase shift, and we're not going to mess with the period. In this case, our a is 1, our amplitude is 1, no transformation there. Our b, what we're multiplying by the x, is 1, so the period is unchanged. And our d is 0, so there's no vertical shift either. Setting what's in the parentheses equal to 0 to get our left point, our graph will start at pi over 3. The first period will start at pi over 3 instead of 0. To get our right endpoint, we set what's in parentheses equal to 2 pi. In order to add pi over 3 to both sides, we need a common denominator. So 2 pi becomes 6 pi over 3 plus our pi over 3. The ending of the first period of our sine function will be 7 pi over 3. In order to scale our x-axis appropriately, remember when we scaled our x-axis with 2 pi, the parent functions, we had pi over 2, pi, 3 pi over 2, and 2 pi. None of those have a common denominator with pi over 3, which is where our transformation is starting this time. So we need to get a common denominator, which is pi over 6. The scales on the x-axis that are set up for us, I'm going to call them being spaced by pi over 2, because that is a quarter of a rotation for our 2 pi, just like the parent function. That's how we scaled them in the first place. But in order to start at pi over 3, we'll have to add that scale in. Pi over 3 is just shy of pi over 2. So I'm going to create these new scales here, just shy of the ones that are given, in order to get the ones that we need for this to be scaled appropriately. When I add pi over 2, I have pi over 3. I'm adding the pi over 2 for a quarter of the rotation for a period. Common denominator is 6, so I have 2 pi over 6 plus 3 pi over 6, which gives me a total of 5 pi over 6. Adding another 3 pi over 6, or the pi over 2, I get 8 pi over 6, which simplifies to 4 pi over 3. Adding another 3 pi over 6, I get 11 pi over 6, because remember I'm adding it to the 8 pi over 6 that I just had. Adding 3 pi over 6 again, I get 14 pi over 6, which simplifies to 7 pi over 3. Because of the phase shift, I can't just reflect those points off to the left. I have to take my left end point for that first period and subtract that quarter of a rotation this time. So we have 2 pi over 6 minus 3 pi over 6, which gives me negative pi over 6. That will be a little bit closer to 0 than it will be to the pi over 2. And then I have to subtract another 3 pi over 6, which gives me negative 4 pi over 6, or negative 2 pi over 3. And all of these will be a little bit closer to the tick mark on its right than on its left. Just like off to the right, all of those were closer to the tick mark on the right than they were on the left. Negative 4 pi over 6 minus 3 pi over 6 gives me negative 7 pi over 6. And subtracting another 3 pi over 6, I get negative 10 pi over 6, which simplifies to negative 5 pi over 3. My y-axis, the amplitude was 1, so I'm going to scale those at 1 and negative 1. Now to graph my sine function, I'm going to start at that phase shift. The sine function starts at 0, and each of those red tick marks is where I'm going to be, up to the maximum, back to 0, down to the minimum, and back to 0. And off to the left, it does the opposite, down to its minimum at the red tick mark, not the y-axis, back to 0, up to its maximum, and back to 0. And there are 2 full periods of our sine function with a phase shift of pi over 3. Taking a look at a basic phase shift of our cosine function, again, that a value is 1, so our amplitude is 1. We're multiplying x by 1, so our period remains 2 pi, and we don't have a vertical shift. We're just focusing on that phase shift this time. Setting x plus 4 pi equal to 0, we have a left endpoint of negative 4 pi. And setting x plus 4 pi equal to 2 pi, we have a right endpoint of negative 2 pi. Our period was 2 pi, which means we can scale these by pi over 2. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So there's the right endpoint for our first period. Negative 5 pi over 2, negative 3 pi, negative 7 pi over 2, and negative 4 pi. So there's the left endpoint for our first period. Amplitude was 1, so we're going to scale our y-axis at 1 and negative 1 again. Starting all the way out at negative 4 pi, cosine starts at its maximum, then it goes to 0, down to its minimum, back to 0, up to its maximum. There's 1 full period of the cosine function. We're going to do another one just heading in the same direction, back to 0, down to its minimum, back to 0, and ending at its maximum. That is a phase shift of 4 pi for our cosine function. In the next video, we're going to take a look at putting the phase shift together with the other transformations that we've already seen.